In today's class, we are going to see covariance matrix. So what is a covariance matrix is, it summarizes the relationship between multiple variables in a data set. That is a covariance matrix. So mathematically, we are going to just see that how we are going to find a covariance matrix. Okay, so we are just going to take an easy example. Suppose we have two images. Okay, so we have two images and each image has a size of 4 pixels. So I'm going to name it as image A and image B. So image A, if I'm taking, I have 4 pixel values, a very small image I'm taking. Okay, so this is how the pixel values are represented in a form of a matrix for image A. Likewise for B, the pixel values would be, okay, so here I have two images with 4 pixel values. So with this data, we are going to construct a covariance matrix. So the first very step is called as flattening. Okay, so what is the thing done in this flattening is, each image, it becomes a row vector. Okay, so keep in your mind, flattening means each image, you're going to bring it as a row vector. So for our problem, we have just taken two images. Okay, so image 1, if you flatten it, it will become, this is image 1. Next, we are going to take image 2. Okay, so we have two images. What we have done is, image A, we have written as a row. Likewise, image B also, we have written it as B. Okay, so now we name it as the flattened matrix. And the name what we are going to give for this flattened matrix is nothing but X. Okay. Okay, so the first step in your covariance matrix is to flatten the image. So what you do is, each image, you convert it as a row and you frame a matrix with it. Okay, so this is your very first step. Second one is center the data. Okay, so how do you center this data is, the very first step for centering the data is, mean for each column is found. Mean for each column. Okay, so here you're taking mean for each column. Second one, what you have to do is, after you find the mean, you have to subtract from each pixel value of the corresponding column. Okay, so what you're doing here is, first you're going to find the mean, then that is mean column wise, then for each element in the column you're going to subtract with the mean. Okay, so how do you do that is, how do you find the mean is, your actual data you had in the first column 154 and 150, so you will just add both the things, so you get 204 and then you divide by 2. Okay, so for the first column the mean is 152. Likewise, you will repeat it for all other columns. Okay, so now coming to the second column, you have 137, 140. So when you add it, it will be 277, and the mean for that is, you have two columns, the two elements, so you divide it by 2. Okay, likewise for the next one, and lastly for the last column. Okay, so once you are done with this, you name that as X-centered. Okay, so X-centered, how do you find the matrix for your X-centered is, your mean is 152 is, right, for the first column. So here the first element is 154, so it will be 154 minus 152. So the first element would be 2. The next element would be 150 minus 152. So it will be minus 2. Okay, likewise, if you take for the second one, it will be 137 minus 138.5. So it is minus 1.5. Next one, 140 minus 138.5. So it will be plus 1.5. Here it will be 40 minus 45. So it is minus 5. And here it will be plus 5. Likewise, 34 minus 32. So you'll have this new matrix. Okay, so why is that you're finding this is, when you're taking the image, this matrix, this X-centered matrix, it will remove the overall brightness and focus only on the variation, so that we add this step. Okay, so after this, your step 2 is over. Next, what you have to do is covariance matrix. Okay, so covariance matrix, how do you find the covariance matrix is by using the formula. So the formula is 1 by n minus 1 X transpose centered into X-centered. Okay, so this is the formula. So here n is nothing but the number of images. So in our problem, we have just considered two images, so your n is nothing but 2. Okay, so now we are going to put everything into the formula. So we know what is X-centered and X transpose centered. So X-centered was nothing but 2 minus 1.5, 1.5 minus 5, 5, 2 and minus 2. This was our X-centered. Okay, so obviously our X-centered transpose would be 2 minus 1.5 minus 5, 2 minus 2, 1.5, 5 and minus 2. This would be our X transpose centered. Now we are going to find the covariance matrix. I'm going to name it as C. Okay, so 1 by n is nothing but 2. So it is 2 minus 1 into x transpose is nothing but 2 minus 2 minus 1.5, 1.5 minus 5 plus 5, 2 minus 2. Then my x is nothing but 2 minus 2 minus 1.5, 1.5 minus 5, 5, 2 and minus 2. We're just going to multiply normal multiplication. Okay, so it will be 2 into 2 plus 2 into 2. So the first one will be 4. The second one will be minus 1, sorry, 2 into minus 1.5. Then again 2 into minus 1, minus 2 into 1.5. So it will be obviously minus 3, which is minus 6. Okay, so you will do normal multiplication and find all other elements. So here it will be minus 6, next it will be 4.5, then it will be 50, minus 6, minus 20, 50, 50, minus 20, 8, minus 6, minus 20 and 8. Okay, so here what you can observe here is leaving the diagonal. Okay, so here when you're naming it with numbers, so this will be A12. So A12 is minus 6, A21 is also minus 6. Likewise A13, A31. Likewise A14, A41. So A12 will be equal to A21, A13 is equal to A31, A14 would be equal to A41. Likewise, when you're taking these terms, so it is A23, so this will be equal to A32. So you can see this. Likewise, these two elements are same and these two elements are same. So what does this similarity tell you is this is a symmetric matrix. Okay, so this is all about the covariance matrix.